we have established the XY coordinate system as our frame of reference. Note the fact that we place Y here means that positive values will be on this side, negative values over here. The X being placed here means these values are positive and over here negative. What I'd like to do now is more explicitly relate these axes to the real world. As you progress through this course, you'll find yourself having to solve many problems. And a very important part of solving a problem is being able to read it and determine exactly how you'll represent the situation described using a pair of axes like these. Here we have a pair of axes that form a plane that is perpendicular to the surface of this table. Suppose we have the point 2315. Well, that would be a point that would be 23 centimeters along this edge, away from here, and up 15 centimeters. So let's say about here. And so all the points that we work with will be in this plane and above this edge, right above this edge. Now, when you're trying to solve a problem, you don't need to draw anything fancy like this. Just draw the axes. So just recapping, this axis is along the edge of this table, and this axis is perpendicular to the table. So all these points are above the table and right above this edge. In this case, the axes form a plane that coincides with the surface of this table. So the point 2315 would now be on the surface of the table itself. So let's suppose that the table is big enough that the point 2315 fits right here. If we use larger numbers, the point probably would not be on the table itself, but it would still be on a plane that is parallel to the surface of this table. The point is that our XY coordinate system can be parallel to the surface of the earth, or it can be perpendicular to the surface of the earth, as we see here. So here the plane is vertical, here the plane is horizontal. If you notice, in this case the angle here is not 90 degrees, and we want to always have 90 degrees between our Y and X axes. So I only drew this here like this to make the case. However, in actual fact, you will always be drawing your axes like this. So this situation that we have here indicates that we have a point at 2315. So what this actually represents in a physical sense depends on the problem. All these points here could be points on a horizontal plane, or these could be points on a vertical plane. You would know from the context. When you read the problem, you decide to represent it like this, and of course it would then be perfectly clear in that situation. So this could be a point, let's say, on the surface of a table that's 23 centimeters from one edge and 15 centimeters from the other edge, like we see here. Or it could be a point 23 centimeters along this edge and 15 centimeters above the table, as we see here. When solving certain types of problems, it's easier to use tilted axes. Note that the axes are still perpendicular to each other. So the x-axis is at 90 degrees to the y-axis, but the entire system has been rotated somewhat. Doing this makes solving problems involving situations like these easier. As this object moves down, let's suppose you have a crate here sliding down this inclined plane. As it does so, only its x values change. The y values remain the same, 0. So this makes for a much easier problem to solve. Now, there's nothing wrong with, say, putting the axes like this. You could put your axes anywhere you want to, and you should still be able to solve the problem. But one choice will lead to an easier problem, and another choice will lead to a harder problem. In other words, the ease with which you can solve the problem will depend on where you place your axes. So in this case, as this object slides down this ramp, both its x and y coordinates change. So that would be an added element that you would need to consider as you try to solve the corresponding problem. When solving problems, a major decision you have to make concerns the placement of your axes and the orientation. Deciding this can be somewhat of an art form, but solving many problems allows you to develop a sense for it. As we like to say here, you develop the art. So that's the only good answer I have for you. Solve many problems. The more problems you solve, the easier it becomes to make this decision. However, bear in mind that even very experienced problem solvers can choose different axes because after a while you develop your own style. You prefer working in a certain way. Again, practice and develop your own style. Bear in mind that as you choose your axes, you want your choice to facilitate your solving of the problem. So that should influence your decision making. Pick axes that make the problem as easy as possible to solve. So for example, suppose you have a problem involving a plane and the plane flies between Belmopan, Belize City and Anguilla. How do you set up your system of reference in this case? Well, one person could decide to set it up this way. Place the origin at Belmopan, and then Belize City would be at 4017 in miles, and Anguilla would be at 37 minus 33. In a real situation, if you're trying to solve a problem, you would not necessarily try and draw this map. I'm just drawing this here to illustrate what I'm trying to say here. You don't have to place the origin here, however. You can place the origin here, in which case now Belize City is at 0, 0, Belmopan is at minus 40, minus 17, and Anguilla is at minus 3, minus 50. So is any one of these choices better? Well, probably not. Maybe in the context of the specific problem, it would maybe be obvious that this choice is better or this choice is better. The thing is, you have to make a choice. So that's it for this video. As we move through this course, you'll get a lot of opportunities to practice all of this.